The Zurich University of Applied Sciences is one of the 3 universities in the state of Zurich. And there are 4 locations. And on those 4 locations, we are teaching engineering, economy, life sciences, healthcare, communications and linguistic, architecture and design. There are 5,000 students and we are like 1,500 employees here at this location. At the school we teach a bachelor's and a master, and besides teaching we have also a research and development task. And the research and development tasks we do at the institutes. And we are here at the Institute of Embedded Systems. So our specialty is, for example, real-time Ethernet and everything that has to do with communications. Ultra Wideband is one part of it, and wireless. Research and development you can divide into different categories. And basic research is what they do on the big university like Harvard or Berkeley. Then you have the field of applied research and development, and you have the field of industrialization. Industrialization is what they often do at companies. And our focus is in applied research and development. So that means we are finding ideas, we're doing feasibility studies, and we are doing concept development.
We are developing a wireless video endoscopy system for medical applications. One of the novelty of the system is it uses wireless transmission of the live video data stream between the endoscope, that's the camera, and the display in a small monitor package. Some of the key requirements on this system are real-time video data transmission, which means hardly any latency between the signal at the camera and the signal at the display. High bandwidth, so we can transmit relatively high resolution video signals in real time. And low power consumption, because both the monitor and the endoscope are portable mobile devices which are operated by battery power. We partnered up with the Institute of Embedded Systems to develop a prototype for this product. The Institute suggested to use Ultra Wideband technology, which turned out to be a good solution. We were then looking for technology components that fit the requirements, and one possible solution is the CAP microprocessor by Atmel, which has a small footprint. It has the low power consumption required and lets us implement the media access controller for the ultra wideband transmission.
So, I would like to tell you a little bit about UWB, so Ultra Wideband. This is a telecommunication standard that is suited for the usage of personal area networks, or PANs. The basic idea is started with the standardization of a large bandwidth standard that would use at least 500 megahertz or up to 20% of the carrier frequency. In the beginning there were 2 industry consortiums trying to establish this protocol, and in the end the one which dominated is the one from Y-Media. And what happened now is that this has been standardized by the European Regulating Office, ECMA. So what we are talking here about is the ECMA standard 368 and 369, which are describing the physical and the MAC or medium access layers of this UWB standard.
On the camera architecture itself, we do have several components, and one of the components is the ultra wideband PHY, is the radio part. And the radio is not always available to send because there may be other transmitters on the channel. So we have to account for that the data stream is sometimes stopped. However, our NTSC camera is constantly taking pictures. So we need to have a buffer that when the data flow is stopped, the NTSC camera data are not lost. So we need a buffer to store those data. On this camera we do also need a light, and then light needs to be controlled in intensity. We do have a user interface where the physician can command to take a snapshot or to start and stop a video camera. And in addition, we do have a battery which needs to be monitored and which needs to be charged. When we looked at our architecture, we found out that the Atmel CAP9 supports that architecture a great deal. One part is the data flow. In order to bring the video data in our intermediate storage, we are using the AMBER host bus. We designed a digital video interface which streams the video data directly onto the AMBER host bus, from where it can be picked up by the EBI controller, the SDRAM controller in the CAP9, and stored in the SDRAM. In order to send out the data to the Ultra Wideband interface, we can use again this AMBER host bus. In that function, we switched the Ultra Wideband MAC as a bus master, which picks up the video stream from the SDRAM and sends it out to the radio interface. So the whole design can be done with a very small parts count. We only need the CAP9, a few analog parts, and the RF transmitter. So what you see here is the result of our development. On the screen you see on the right side the data transmission rate of the video, and you see also the percentage of the failure rate. And you can see that even though we're going through a 30 centimeter thick wall, the error rate is relatively small. So the reason why we think that the CAP is the best solution for us, it's because it's the availability of the standard microcontroller and peripherals, and the ability to implement our own design. And this results in a product solution that is compact and cost effective. So as a result, we reached an architecture that's consisting of two parts. One part is the microcontroller part, and the other part is the mass programmable part, where there is our Ultra Wideband MAC and the digital video interface. And both are connected through a backbone, and the backbone is the AHB, the AMBER host bus. Now we have the possibility to either feed data from our digital video part into the Ultra Wideband interface, or we feed any data from the microcontroller part via the AHB bus to our Ultra Wideband interface. That means all the resources that are available in the CAP9, the I2C bus, the USB, can be used as a data source for the Ultra Wideband transmission. So we have kind of a universal Ultra Wideband controller chip. So the Institute of Embedded Systems and Atmel would like to work with you implementing your Ultra Wideband solution onto a CAP.